Good afternoon, everyone. So, in today's class, we will discuss the atomic structure. So, the things important in this one, so if you see the PAQs, the important topics mostly from wave parameters and then related to even Planck's quantum theory and wave parameters. And then after that, we are getting mostly from the Bohr's concept, that is energy, right? And energy, radius, and then after that, we are getting from the spectrum. We are getting the spectrum, and we are getting that this different spectral series, that is Lyman, Balmer, Paschen, bracket, Fund. So, what is the wavelength of that so and so line? Right, or else the longest wavelength or shortest wavelength. So those things they are giving, and apart from that one, now here and there they are giving the questions from the de Broglie equation and next Heisenberg uncertainty principle, and mostly you are getting from the quantum numbers. And in 2026, whatever the paper that was cancelled, in that one you can see the question came from. One is from the textbook, right? That is the 150 watts, 8% of energy, and the energy of one photon energy is given, and then how many photons are emitted. They ask the question. So that is from the direct from the textbook itself, right? And next one more question they gave n and l values for the different n and l values they gave, and these values belongs to which orbital. So that is from quantum numbers they give. So mostly if you say from which topic you have to start the preparation in this chapter is quantum numbers. That is every time they are asking in most of the exams, in NEET and in the state level exams, right? In the EPSET and in the JEE also, they are more concentrating on the quantum numbers. So quantum numbers you have to consider first, and after that the Schrodinger concept. In that one, radial nodes, angular nodes, total number of nodes, and then comes to the Bohr's concept. In that one, energy and radius and the spectral series, that is Lyman, Balmer, Paschen, bracket, Fund, H alpha line, H beta line, or infinite line, H infinity, that is means infinite line. So like this, all these things they are asking. So majorly concentrate on quantum numbers first, then come to the Bohr's concept, then miscellaneous, that is from the wave parameters, energy concept, photon energy concept, then the photoelectric effect and Planck's quantum theory and electromagnetic radiation. Then after that de Broglie equation, and then Heisenberg uncertainty principle and Schrodinger concept. So this is the way of reading or revising these topics. So let's start the atomic structure. So we will see in this order in today's class. Now first we'll see in this order. So we'll discuss about first introduction to the atoms, and then electromagnetic spectrum, and then Bohr's model of atom, and then wave and particle nature, that is de Broglie concept we'll discuss. So one by one we'll discuss in a sequence. We'll discuss in a sequence. So first one, atomic number. See, these are the small things. I'm not going to give much time to these topics because already you are learning from 8th, 9th, 10th also. So atomic number, that is number of protons and number of neutrons. Number of neutrons we should not take. Number of protons and number of electrons in a neutral atom. So we can, whenever taking number of electrons, you have to mention neutral atom, right? Because electrons atom may lose electrons, atom may gain electrons. And mass number is number of protons plus number of neutrons. So number of neutrons, number of protons may be equal, may not be equal, right? May be equal, may not be equal. If let's take isotopes, if you take isotopes means the elements are having same atomic number but different mass number. In that one you take hydrogen, that is protium, deuterium, tritium. The protium, one proton and one electron, there is no neutron. And deuterium, there is a one proton and one neutron, one electron. And tritium, protons, right? So protons plus neutrons are called as nucleons. Next, you know this representation. So mass number will represent here, atomic number will represent below. So these values you have to remember means it's a general thing. It's a general thing. So you will remember, you will not remember. It's not that much important here. Questions also. This is a basic thing you have to remember. If you remember, it's better. Next. So here I will add one thing in this one, in the slides. I'll add one thing. The one thing is E by M ratio. So they are asking the E by M ratio. E by M ratio they are asking. So in this, what is this E by M ratio? E means charge and M means mass. So E by M ratio, if you take in this one, which one you are going to get more? So they will give electron, proton, neutron and alpha particle. Electron, proton, neutron and alpha particle, and they will ask the particles arranged in the increasing order of their E by M ratio or arrange them in the decreasing order of their E by M ratio. So E by M ratio, there is charge to mass ratio. Since it is a comparison, you can take the relative masses, you can take the relative masses, you can take, there is no need to take the absolute values, right? So E charge of neutron anyway it is 0, and alpha particle means doubly charged helium particle, helium ion, sorry. So that is helium 2 plus, means its charge is 2 and its mass is 4. That is for helium. And then electron it is 1 by, it is electron, the mass is 1 by 1840 times to that of proton mass, relative mass if you take. That means here you can take, that is electron, you will get the more value. So electron is the highest E by M ratio, next proton, and next alpha particle, and least is neutron, because neutron is charge is 0, E by M ratio 0 by anything you will get 0. So neutron you will get 0, and alpha particle you will get half, and next proton you will get 1, and electron you will get 1, sorry, the 1840 you will get. That means electron is having the more value. Okay, absolute values if you take, you will get different one. Since it is a comparison, they are not going to ask absolute values. They will ask to compare which is having greater, or in the increasing order or in the decreasing order they will ask. Fine, next. So highest is electron, second highest is proton, third highest is alpha particle, and fourth least one is neutron. Neutron is the least one. Next one, isotopes. Okay, isotopes, you already know these things. Isotopes is means having same atomic number, isobars means having same mass number, and isotones means having same number of neutrons, and isoelectronic species means having same number of electrons. Here the question little bit, if you see in these things, isotones, let's take isotones. Isotones are having same number of neutrons. Is atomic number and mass number is same? No. You can see atomic number is same? No. Mass number is same? No. But number of neutrons are same. So A is different and Z is also different. Z is different means number of protons are also different, but A minus Z, that is number of neutrons is same. A is different, Z is different, but A minus Z is same. That is considered as isotones. And isobars, A is same and Z is different. Since Z is different, number of protons are also different. Next. So simultaneously we will solve few questions also here. So to get more clarity. So if you see, select the correct statement from the following. Atoms of all the elements are composed of two fundamental particles. Atoms of all the elements are composed of two fundamental particles. Okay, two fundamental particles. Okay, here you will confuse maybe all the particles. Okay, two fundamental particles, three particles are there, na? Electrons, protons, neutrons. Then we'll see. Wait, I'll explain. The mass of the electron is 9.1 to 10 power minus 31 kg. So this is 2023 NEET question. Said you have to remember those values means since they ask you have to remember. All the isotopes of given element show same chemical properties. Isotopes are having same chemical properties. Yes. Protons and electrons are collectively known as nucleons. No. Dalton's atomic theory regarded the atom as an ultimate particle of matter. Correct. So now in these options, you have to select which one is correct. So which one is correct? Let's take few seconds and see. Okay, maybe this side able to see. Anyway, all the okay, protons and nucleons together is considered as nucleons. Rho is wrong. So D option should not be there. So eliminate the D. And all the elements are composed of only two fundamental particles. No, all the elements only two fundamental. Three fundamental particles. Na electrons, protons, neutrons. So obviously that A is also wrong. So A should not be there means. So our answer will be C. So A should not be there and D should not be there. So A and D should not be there means the answer will be B, C, E. So B, the mass of the electron, correct, and the C, all the isotopes. Since atomic number is same, so the properties, chemical properties are also same. Next, and E, Dalton's atomic theory regarded an atom as an ultimate particle of matter. Yes. So what Dalton said, we cannot divide the atom. Atom is itself is the smallest particle, and in fact that is the defect of Dalton's theory. Next question. From the following pairs of ions, which one is not an isoelectronic pair? This is NEET 2021 question. So which is not an isoelectronic pair? So isoelectronic means same number of electrons. It should have same number of electrons. Now in this one, which is having same number of electrons, which is not having same number of electrons. We know that Na plus and Mg plus 2, they are having the same number of electrons. So this is not the correct answer. And next, O2 minus F minus, they are having the same number of electrons. Now this is also not the correct answer. Next, Mn2 plus. Now manganese, it is 25 and 2 electrons you removed and it is 23. And iron, it is 26 and 3 electrons are removed. So it will be 23. And Fe2 plus and Mn2 plus. Fe2 plus, it is 26. 2 electrons are removed, it's 24. And manganese, 25. 2 electrons are removed, so it will be 23. So answer is second option. In the second option, you are not having same number of electrons. Simple questions. So this is NEET 2020 question. The number of protons, neutrons and electrons in lutetium 175 and 71 respectively. Simple question, this one also. Whatever the number, this is number of protons only, right? And they are asking number of neutrons. Neutrons means 175 minus 71 because A minus Z. So this is A minus Z, that is equal to, right? Next one is, and electrons. Electrons are also 71 only. Electrons are also 71. 71 at last you have to get. So the answer is first option 71, 104 and 71. Next one. Okay. So next topic, we will see electromagnetic spectrum. Electromagnetic spectrum. So in this electromagnetic spectrum, we will see the characteristics of the wave and Planck's quantum theory. Okay. Characteristics of the wave and Planck's quantum theory. Right? Okay. So this is electromagnetic spectrum. It starts from cosmic rays, and it's cosmic rays. You can see here electromagnetic spectrum. Okay, they didn't mention the cosmic rays, but the highly energetic one, they are the cosmic rays here. The highest one is cosmic rays. So cosmic, next gamma, next X, next UV, next visible, next IR, next micro, and next radio and long radio waves. So in this one, highest energetic, see, this is the spectrum. This is nothing but the arrangement of all the radiations in the decreasing order of their energy or in the increasing order of their wavelength. All are interrelated. So you can say in any one term. Either you can say in terms of decreasing energy order, So cosmic rays, gamma rays, X-rays, UV rays, and visible and IR, micro, radio, right, and long radio waves. So in this one, cosmic rays are highly energetic, and next gamma rays and X-rays and UV. See, this is according to the wavelength. Here it is wavelength is less, so wavelength is in the increasing order. Wavelength is in the increasing order, right? Our energy is decreasing order because all are interrelated. So in this one, you have to remember the, anyway, I think you remembered 400 to 750 nanometers, or else 4000 to 7500 angstroms. So you can remember in angstroms, you have to remember in angstroms, and you have to remember in nanometers, right? Okay, so here majorly you have to remember X, visible, IR. So IR will come after the visible and UV will come before the visible. So main characteristics of a wave: wavelength, frequency, velocity, wave number, and amplitude. We will see. Already you know all these things, what is the wavelength and what is, right. So what is the wavelength and what is this amplitude, all those things. I am not going to say all those things. Already you learned these things. So here wave parameters, if you see, nu is equal to, that is nu is nothing but frequency. Nu is equal to c by lambda. So lambda is nothing but wavelength, c is velocity of light, right. Next, nu bar, that is wave number. This is wave number, and wave number is equal to inverse of wavelength, right. Okay, next. So those things only we are going to use again and again. This is Planck's quantum theory. The smallest particle of energy that can be emitted or absorbed is called as quantum. So quantum is, specifically if you say, it's an energy of, it's a bundle of energy. It's a bundle of energy, a packet of energy. And each energy of each quantum is having a particular energy, and that energy is directly proportional to its frequency. So that E is directly proportional to frequency, and if you remove this proportionality constant, E is equal to h nu. That is, h is equal to Planck's constant, that is Watt's value is 6.62 into 10 to the power of minus 34 joule into second. So if you relate the energy and the wavelength, anyway we know that nu is equal to c by lambda, just now we written. So E is equal to hc by lambda. So from here you can see E is equal to hc by lambda. So hc by lambda means E is equal to hc by lambda we are writing. Here h is anyway constant and velocity of light is also constant. So energy is inversely proportional to wavelength. That means energy is more and wavelength is less, vice versa. So here, if you remember these values in direct, if you remember these things, you can do the questions little bit very fast. That is also important, no? How much fast we are doing. So if you want an electron volt, then 12,400 by the lambda which is given in the angstrom. Or else if you want, the lambda is given nanometer, then 1240 by lambda in nanometer. So you can find the energy in the electron volt. If they are given angstroms, take the numerator 12,400, and if it is given nanometer, take 1240. Try to remember these formulas, so it will be easy to solve the questions. So let's solve few questions again. If the frequency of radiation is A hertz, that is frequency, nu is equal to is given A, and the total energy of radiation is energy is given E, then the number of photons emitted in the radiation, see, this is E is equal to h nu. This is energy of one quanta. one quantum. This is energy of one quantum. If energy of 2 quantum, then we'll get 2 h nu. If it is 3 quantums, 3 h nu. If it is Avogadro number of 1 mole of quantum, that is Avogadro number of quanta, then E is equal to Na h nu. Right? So now they are asking here the frequency of radiation is AH and total energy is E, and they are asking then the number of photons emitted in the radiation. So you have to find the number of photons emitted in the radiation. So number of photons means that is, see just now I written E is equal to, if it is 1 quanta we are writing 1 h nu. If it is 2 quanta we are writing 2 h nu. If it is n quanta we are writing n h nu. If it is Avogadro number of quanta, that is Na h nu. So since we are writing for only one, since we are writing only for one quanta, so we are writing E is equal to h nu. So how many quanta? They are asking the number only now. So they are asking the number. Now E is, you have to take now E is equal to NH nu. And h nu is given as a and energy anyway they give E only. So they are asking how many quanta. That means they are asking this n value. This n value. So the answer is C1. Next question. These are all the simple questions they used to give. Now also they are giving, but little bit change they are doing, and they are giving the questions. The frequency of yellow light having the wavelength is 600 nanometers. Now I'm not going to solve only these type of questions. Very rarely you are getting nowadays. Nu is equal to C by lambda. Right? They are asking frequency. So frequency, now velocity of light you can substitute, and wavelength they give 600 nanometers, you can substitute and you will get the answer. This is NEET 2021 question. A particular station of All India Radio, this is also directly from, I think, from textbook. I think the values little bit changed or directly they gave. COVID time. So New Delhi broadcast and frequency. So frequency is given, but they gave in terms of kilohertz. Multiply with 10 power 3, so you will get hertz. The wavelength of electromagnetic radiation, emitted by the transmitter. So they are asking wavelength. Again same thing. So nu is equal to C by lambda. What they are asking? They are asking the wavelength of radiation. So that means lambda is equal to C by nu. Frequency is given. Velocity of light you know. So substitute, then you will get the answer. So the answer is 219.3 meters. 219.3 meters. Right. So that is about the Planck's quantum theory and wave parameters. Next one is we will see Bohr's model. Next we will see the Bohr's model of an atom. So Bohr's, he said the electrons are revolving in a circular path and those are called as orbits. They named as KLMN from starting inside. KLMN. Right? And the energy of those orbits is, the electron which is revolving in those orbits, it will be constant. It's not going to change. That's why they are called as stationary orbits. And when the electron is revolving in the stationary orbits, it's not going to lose energy, it's not going to gain energy. If it gains energy, it will jump to the higher levels. And if it loses energy, it will come to the lower levels. And when we are moving away from the nucleus, the energy of electron is going to increase. Energy of electron is going to increase. That means the electrons which are present in the far shells are having more energy far from nucleus. And the electrons which are having near to the nucleus are having less energy. And if electron gains energy, it will jump to the higher levels. How much energy it is gained? That is, change in energy is equal to E final minus E initial. And also he said the angular momentum of an electron revolving in a circular path is equal to integral multiples of h by 2 pi. That is, the angular momentum of electron revolving in a particular orbit, that is MVR, is equal to integral multiples of h by 2 pi, that is nh by 2 pi, n integral multiples, any 1, 2, 3, 4. So, these are the postulates of Bose. So, in this one, from postulates, they are not asking anything. From the derivation point of view, the energy, he calculated even the energy of electron, he calculated even the radius of an orbit. So, from those things, they are asking the question. So, all these things, this is, okay, kinetic energy is equal to minus of total energy, and potential energy is equal to 2 into total energy, and frequency, that is, frequency is nothing but 1 by time, that is v by 2 pi r, and time is equal to 2 pi r by v, and next radius is equal to 0.529 into n square by z, where n is the orbit number, z is the atomic number. If it is the hydrogen, we'll take its value is 1 only, and energy is given here, 13 minus 13.6 into z square by n square. This is in electron volt. If you want in joules, you take a minus 2.18 into 10 to the power of minus 18 joule per atom. So mostly they will give two things, either joules or else they will give electron volts. Mostly 90% they will go for the electron volts only. So if you, but safer side, you can remember the joules also. That is 2.18 into 10 to the power of minus 18 joules into z square by n square. Z is the atomic number and n is the orbit number. Right? And velocity of an electron revolving in a particular orbit. Velocity of an electron revolving in a particular orbit is nothing but 2.18 into 10 to the power of 6 z by n. So z by n here, you can see this value is anyway constant value, and consider hydrogen, it is means z value is 1. Then this velocity is inversely proportional to orbit number. That means as the orbit number is going to increase, the velocity is going to decrease. According to Bohr's concept, as the orbit number is going to increase, the velocity of electron is going to decrease, because the velocity is inversely proportional to orbit number from this equation, orbit number. So, as orbit number is going to increase, the velocity of electron revolving in a particular orbit is going to decrease. This is according to Bohr's concept. Right? So, in this one, majorly they are going to ask potential energy, total energy, kinetic energy ratios. Right? And anyway, energy calculations, and then radius calculations, that is r is equal to 0.529 into n square by z. So let's take one question here. What is the ratio of first orbit to second orbit, a second orbit to third orbit of the hydrogen atom? Radius ratio of the hydrogen atom of the second orbit to third orbit. The ratios you have to learn. Like that, the questions they can ask. Energy also. So let's take the energy of electron, hydrogen atom, let's take. For hydrogen, there is only one electron is present. So according to Bohr's theory, irrespective of electrons, these shells are present. So when electron gains energy, it is going to get these higher levels. Right? So let's take the first orbit energy is 1 joule, consider, for easy understanding. Second orbit 2 joules, third orbit 3 joules, consider. Now the electron is present in the first orbit is having 1 joule energy. Let's consider it is gained 2 joules energy from the outside, from the sunlight or from the outside. Now it's having energy of 3 joules. Now 3 joules means where you should go now? 3 joules is energy of third level. So obviously the electron will jump to the third level. But actually it should present in the first level only. That is why going to the higher levels, that is considered as excited state. And excited state is not a stable condition. So soon the electron will release that energy and again it will come back to its original place. And this is the reason, because of this is the reason we are getting the colors in the flame test, if you remember. So flame test, calcium brick red and strontium crimson red and barium apple green. right? Okay, these three majorly, because okay, lithium, sodium, leave it, that's it, because these three things you are going to do, you did in the lab. That's why I said reference with these three only: calcium, strontium, and barium. So in this one, why they are showing the flame test means because of this reason only. When you insert the salt by adding with concentrated HCl, the electron will gain energy from the Bunsen burner and it will jump to the higher levels. But means it will absorb some amount of energy and it will go to the higher levels. But excited state is not stable, and again it is coming back. It will, whatever it will gain energy, it is releases, and then it is going to give a characteristic color to that flame that is specific to the specific atom, specific element. So you can see a characteristic color to that element, because all the atoms will not gain same energy. The electrons present in the atoms of that element will not gain same energy, because number of electrons are different, the effective nuclear force of attraction are different. So obviously the energy of absorption is also different. That's why they will show different colors. This is from Bohr concept explanation only, right? So I think we'll solve few questions on this one, Bohr's concept. Still excited state. Fine. So ionization energy. Here one thing, the energy we had in the negative value. So negative value means here the electron is under the influence of the nucleus. That's why we'll consider this energy is less. And when it is out of the influence of nucleus, then we consider energy is more. That is why we'll say that's why we are writing here negative value. This is under the control of nucleus, means its energy is less. So when it is out of the control of the nucleus, it's free, then we'll consider its energy is more. That's why we'll write then positive value. That is nothing but ionization enthalpy. What is ionization enthalpy? Ionization enthalpy means the amount of energy required to remove the electron. So how much amount of energy to remove the electron? That is 13.6. 13.6. So ionization enthalpy is equal to E infinity minus E1. E infinity minus E1. So right. So we'll get means if it is gains 13.6 electron volt, then the electron will be out of the atom. Out of that atom. Right, man. Next. Binding energy or separation energy of an electron. Energy required to move an electron from any state, that is n, to n infinity. That is also called as binding energy or separation energy. So binding energy of the ground state will take, it is equal to ionization enthalpy only. Okay, drawbacks, they are not that much important. In this one, what is Zeeman effect and what is Stark effect? Splitting of spectral lines in the magnetic field, splitting of spectral lines in the electric field. Electric field is Stark effect, magnetic field is Zeeman effect, and it is explained only for single electron system, not for the multi-electron system. Next, it fails to explain the finer details, that is doublets of the hydrogen atom spectrum. Drawbacks are not that much important. Now line spectrum is nothing but the spectrum given by the atoms, line spectrum. So electrons, when they gains energy absorbed due to excitation or de-excitation of electron. The spectrum obtained is called as emission spectrum. See, we are having two types of spectrum. Okay, spectrum is broadly divided into two types: continuous spectrum, discontinuous spectrum. Spectrum, that is collection of all the energy. Spectrum is of two types, broadly divided into two types: continuous spectrum, discontinuous spectrum. Continuous spectrum, the best example is we have seen that rainbow. There is no gaps between the energies, the colors. Discontinuous spectrum means there are some gaps. Again, discontinuous spectrum is divided into two types: line spectrum. Okay, first emission spectrum and absorption spectrum. Emission spectrum means we will get a bright line on dark background. and absorption spectrum means you will get a dark line on bright background. And next, again these emission spectrum and absorption spectrum are divided into two types. If it is by atoms, line spectrum. If it is by molecules, band spectrum. This spectrum is because of emission, line emission spectrum, band emission spectrum, line absorption spectrum, band emission spectrum or absorption spectrum. Right? So because of emission, you will get the spectrum, that is emission spectrum, you will get a bright lines on dark background. Because of absorption spectrum, you will get a dark lines on a bright background. Because at that point it is absorbing, so you will get a dark line. Or at that point it is emitting, at a particular wavelength it is emitting. At that wavelength, at that particular point, you can see a bright line, that is emission spectrum. You can see a dark line, that is absorption spectrum. So it is because of the atoms, we'll say line spectrum. If it is because of the molecules, we'll say band spectrum. Okay, hydrogen spectrum. Anyway, in this one you have to remember this formula. The formula is to find out the spectral wavelength, the line wavelength. At what wavelength you got the spectral line, right? That is, the formula is 1 by lambda is equal to, 1 by lambda is nothing but nu bar RH into Z square into 1 by N1 square minus 1 by N2 square. So N1 from initial stage where and N2 final stage where it is going. From where to where it is going. From where to where it is going. Right? And here RH is called as Rydberg constant. Its value is 109,677 centimeter inverse. Centimeter inverse. So for fast calculations, you can consider 1.1 into 10 to the power of 5 centimeter inverse, or else 1.1 into 10 to the power of 7 meter inverse. So in this one hydrogen spectrum, we are having total 5 spectrums, that is Lyman spectrum and Balmer spectrum and Paschen, bracket and Fun. Total 5 spectrums we are having. So in this, when you will get line spectrum means if the electron is exciting from first level to any level, that is absorption spectrum. If it is coming from any level to first level, then that is emission spectrum. Both are same. One is emitting, one is absorbing. So Lyman spectrum, it falls under UV region, and Balmer spectrum from 2 to any orbit to the second orbit, then that is visible. It will falls under visible. Paschen, it is falls under infrared, and bracket and P-Fun. These three falls under infrared, near infrared, infrared and far infrared. Next, the shortest wavelength of the wavelength is short, that means energy is more. When electron is excited from its first level, whatever the series you can take, means Lyman you take N1 is equal to 1, Balmer you take N1 is equal to 2, Paschen you take N1 is equal to 3. From first level of its series to last infinite line, then that is considered that for that line we are having a shortest wavelength. The shortest line, the shortest wavelength are maximum energy line, and the longest one is second line. Sorry, the longest line is first line. First line means Lyman series you take, that is N1 is equal to 1 and N2 is equal to 2. So 1 to 2. Balmer series 2. First, the N1 is equal to 2 and N2 is equal to 3. So 2 to 3, the first line. The first line is also called as H alpha line, and that is having the minimum energy or longest wavelength. Minimum energy or longest wavelength. The first line, that is N1 to, okay, we can say N2 is equal to N1 plus 1. N2 is equal to N1 plus 1 you can take. So N1 and N2 is equal to N1 plus 1. This is called as longest line of any series, that is longest wavelength, because energy is short, lambda max, and this is lambda short, that is minimum, lambda minimum or energy maximum. the total number of spectral lines is equal to total number of spectral lines delta n into delta n plus 1 by 2. Right? So we can, this is also question previously they asked how many number of spectral lines, total number of spectral lines. Fine. So let's solve few questions here. In Balmer series, the hydrogen atom spectrum, which electronic transition causes third line. Okay, Balmer series they said. So Balmer series means N1 is equal to 1, sorry, N1 is equal to 2 and N2 is equal to 2, 3, 4, 5. In that one, third line. So first line means 2 to 3. Next, 2 to 4, 2 to 5. So 2 to 5 or else, okay, I said absorption spectrum. Now emission spectrum. Emission spectrum means 5 to 2, 4 to 2, 3 to 2. So 3 to 2 first line, 4 to 2 second line, 5 to 2 third line. So the answer is 5, that is fifth orbit to second orbit. The energy of, next question. The energy of electron in the first Bohr's orbit of hydrogen atom is minus 13.6. What will be its potential energy of fourth orbit? So they are asking the fourth orbit potential energy. See, whatever the value here, see whatever the value we got, 13.6. So is they are asking fourth orbit. Now they are asking potential energy, not the total energy. Whatever the formula we got, energy is equal to minus 13.6 into Z square by N square, electron volt per atom. That is total energy, not the potential energy. So you first find the total energy, then potential energy is equal to twice of total energy. Potential energy is equal to twice of total energy. So by using this formula, you find first the fourth orbit energy, that is minus 13.6. The formula here, E is equal to minus 13.6 into Z square by N square electron volt per atom. So they gave here minus 13.6 into, anyway they mentioned it is hydrogen atom, so it is only 1 square means 1 only, and this is 4 square, that is 16. So if you solve this one, 4 square, that is you are going to get minus 0.85 electron volt per atom. Right? So now this is total energy, it's not the potential energy. Now they are asking potential energy. That means you have to multiply this value with 2, because potential energy is equal to twice of total energy. So if you multiply with 2, then you are going to get minus 1.7. Simple question. But here you have to remember the whatever the value we got, the energy value, it's a total energy value. It's not the potential energy, it's not the kinetic energy. Next question, this is 2024, NEET 2024 question. The energy of electron in the ground state for the helium plus ion is minus X joules. Okay, now this time they gave helium, So here Z is equal to, now you have to take 2. And ground state energy, so first orbit of the electron present in the first orbit, the helium, its energy is minus X joules. Then the electron present in the second orbit of beryllium 3+. Now beryllium 3+ you have to find. This is helium plus, right? Sorry, helium plus. And beryllium 3+ in joules, that the number is 2. That means orbit number is 2. So energy equation, okay, there Okay, and then if you take an energy equation now here, minus 13.6 Z square by N square electron volt. So now here Z value substitute beryllium and N value substitute, and then you find how much value you are going to get. So E is equal to, okay, since it is comparison, not right, okay, no need to do all those things, directly you can compare here. So beryllium plus 3, anyway if you do the calculation also you will get the same things, means, okay, since it is comparison, now here E is equal, EA, energy of an electron is directly proportional to, they gave Z square by N square. So Z square by N square. In case of helium, it is Z is equal to 2 and N is equal to 1, and that value is given X. And for in case of beryllium, and Z is equal to 4 and N is equal to 2, and that value you have to find, and that value also you will get same value, minus X. This is a simple question, direct you can substitute. Anyway, minus 13.6. You need to take directly if you take the ratio. They are asking the comparison value. This is for helium they gave. So let's take helium. Like this you take. If you more simplify if you want, helium plus and energy of and beryllium plus 3. Then you are going to get Z square, Z by N. Okay, I will take square of this one is helium and by helium plus and Z by N of square of beryllium plus 3. So all this one you will get the answer, simple. Here we are having Z value, we are having N value, here we are having Z value, here we are having N value, here we are having this value, and you have to find this value, simple. Okay, this is NEET 2022 question. If the radius of second Bohr orbit of the helium plus ion is, this is second Bohr orbit, that is second orbit. Second orbit is given 105.8 picometers. Okay. 105.8 picometers. What is the radius of third Bohr orbit of lithium 2 plus ion? Right. So here we know the radius formula, that is 0.53 into N square by Z angstroms. So you take this one formula, and now in this one you have to compare now here. So if you have to compare means here again, so R just written 0.53 or 529 into N square by Z in angstroms. So here anyway this is a constant value. If you take now R is directly proportional to N square by Z. So here you have to compare the again helium plus and lithium 2 plus, that is equal to here N square and which one, this is second Bohr orbit, means N is equal to 2 and atomic number of helium is 2 you can take, and this one you have to find, and which orbit they are asking, third orbit, substitute third value, and lithium, that is 3. You substitute all the values, you will get the answer. The answer is here 158.7 picometers, simple one. So substitute the direct formula, and in that one you will get. Okay, next. So based on the equation, next question. Based on the equation, E is equal to minus 2.178 into 10 to the power of minus 18 Z square by N square. Certain conclusions are written. Which of them is not correct? We will read each statement. The negative sign in the equation simple means that the energy of electron bound to the nucleus is lower. That is, would be if the electron were at the infinite distance from the nucleus. Correct? Just now only I said, right? ఎలక్ట్రాన్ హోల్లో ఉంటుంది కాబట్టి న్యూక్లియస్ హోల్లో ఉంటుంది కాబట్టి ఎలక్ట్రాన్ ఎనర్జీ తక్కువ అని తీసుకోవాలి. అదే ఇన్ఫినిట్ డిస్టెన్స్ అంటే బయటకు వెళ్ళిపోయినట్టే. ఇన్ఫినిట్ డిస్టెన్స్ లో ఉంటే ఎనర్జీ ఎక్కువ అని తీసుకోవాలి. లార్జర్ ద వాల్యూ ఆఫ్ n, లార్జర్ is the orbit radius. Radius is nothing but nucleus to the outermost shell. If it is a shells increasing, the radius is going to increase. Equation can be used to calculate the change in energy when the electron changes the orbit. Okay, electron changes the orbit, we can find the energy. Yes, we can find. For n is equal to 1, the electron has more negative energy than that of n is equal to 6, which means that the energy is the electron is more loosely bound in the smallest allowed orbit. So smallest orbit, that is loosely bound, and the smallest orbit is loosely bound. The smallest orbit is loosely bound, it's tightly bound now. See, electron closer to the nucleus is strongly bonded. It's not the loosely bonded. A simple line they are asking. It's not the loosely bond. It's strongly bonded. Right? So remaining 3 are correct. And which is not correct they asked. So the last one, which is strongly bound. It's not the loosely bounded. Next, wave and particles nature of electromagnetic. Okay, wave nature, reflection, refraction, interference, diffraction, dispersion, and particle nature, black body radiations and photoelectric effect. Right? So in this one, these things I am not going to discuss now. Anyway, you know better than me. In the physics, you know all the things. So this is black body radiation. The black body is the body which can absorb all the radiations and emit all the radiations. Right? And in this one, if this curve is important, the intensity and wavelength curve. So initially when you heat the iron rod, you will get a dull red, next red color, and next white color, and next blue color. Right? That means intensity is going to increase, and after that longer wavelength, the intensity is going to decrease. Right? This curve is important here. The frequency means the emitted radiation of the black body, which depends only on the temperature. Next one, photoelectric effect. This is anyway. Photoelectric effect means ejection of electrons from the metal surface when a light of suitable frequency falls on it. Any light which falls, it is eject means no suitable frequency. It should have greater than threshold frequency. Then the electrons will out. Eject electrons are called as photoelectrons. And the metals which are, let's take first group elements. First group metals, that is lithium, sodium, potassium, rubidium, cesium. So since cesium is the largest one, it will show photoelectric effect at greater extent when compared to the other alkali metals, because cesium is the bigger one, so it requires only less amount of energy. The electron is loosely bound here because the distance is more, so the effective nuclear force of attraction is less, so the electrons can easily come out. All those points only. In this one, this point is important. The kinetic energy of ejected electron. The electrons will be ejected out with some kinetic energy. The kinetic energy of ejected electrons is increases when the frequency of incident light is going to increase. If the frequency of incident light is increased, then the kinetic energy of the ejected electron is going to increase. Is number of ejected electrons is going to increase if the frequency of incident light increases? No. These points they asked previously so many times. Nowadays they are not concentrating, but this is very, very important. When frequency increases, the kinetic energy of ejected electrons increases, but not the number of electrons ejected out. That means number of electrons ejected out is called as photoelectrons. When intensity increases, intensity of incident light increases, number of electrons ejected out is going to increase, but not the kinetic energy. So kinetic energy ఎప్పుడు ఎక్కువ అవుతుంది? Frequency of incident light ఎక్కువైనప్పుడు. Number of electrons ejected out increases when if intensity of incident light increases. So what is the formula? The formula is E, okay, the formula is here, E is equal to E naught minus E naught, sorry, we'll write like this. E is equal, E minus E naught is equal to kinetic energy. That means how much energy that is incident light is having. In that one, how much it will use the energy, threshold energy will be used, and remaining energy will come out as kinetic energy. Right? So, here if you write now E is equal to E naught plus KE kinetic energy. Now E means we know that it is H nu. H nu is equal to H nu naught plus kinetic energy means of mv square. So here work function we can also write H nu is equal to W and plus 1 by 2 mv square. That is W means it is a work function. So from here they are asking majorly the questions they are asking. This is stopping potential. So in this one, okay, the potential that can stop the photoelectrons having maximum kinetic energy from reaching anode, that is called stopping potential. The kinetic energy maximum is equal to E into V naught, that is stopping potential. This is not the thing they are asking majorly. The major thing is here, okay, the velocity of ejected electrons H nu is equal to H nu naught plus kind of mv square. From here, what is the velocity of ejected electrons? That is the thing they are used to ask frequently. Or else, what is the wavelength of ejected electrons? So H nu minus H nu naught is equal to of mv square. So we can take now v square is equal to 2 by m and h and nu minus nu naught. Right? So V is equal to now that is 2h by m and nu minus nu naught. This is velocity, sorry, this is velocity of ejected electrons. Right? Velocity of ejected electrons. From here frequency if they are asking in terms of wavelength, if they are asking the velocity of ejected electrons is equal to 2hc by m into nu is equal to, okay, c by lambda, 1 by lambda minus 1 by lambda naught. This is velocity of ejected electrons in terms of wavelength, and this is velocity of ejected electrons in terms of frequency. Next one, de Broglie hypothesis. This is de Broglie hypothesis. De Broglie said the particles like electrons are having both particle nature as well as wave nature. Both are there. So the formula is lambda is equal to h by mv. Mv is mass into velocity. That is nothing but momentum. So we can also write mv is equal to p. And what is the relationship between wavelength and kinetic energy? I'm not going to do derivation here. So lambda is equal to h by root 2m ke. M is mass of electron, kinetic ke means kinetic energy, and wavelength, and h is Planck's quantum. And what is the relationship between potential? Potential and wavelength means lambda is equal to h by root 2m qv. Charge and v means potential, not velocity here. V means potential. If an electron is accelerated through a potential difference of V from the rest, then, so this is in angstrom, that is under root 150 by V, V is potential, and number of stationary waves MVR is equal to NH by 2 pi. MVR is equal to NH by 2 pi, number of stationary waves. Next one. So we'll solve few questions here. Familiar phenomena of rainbow, the childhood question, that is dispersion of light. Dash phenomenon which two waves superpose and dash is slight bending of light. One is interference and one is diffraction. You know this one. The perfect black body is one which transmits all heat of radiations, which emits and absorbs radiations of all frequencies. Which emits and absorbs radiations of all frequencies. Next one. An iron rod is heated, the colors at different temperatures are noted. Which of the following colors shows that the iron rod is at lowest temperature? That is dull red. Since dull red is not there, so red color will take here. Electrons are ejected from the certain metal when either blue or violet light strikes on the metal surface. However, only violet light causes ejection of second metal. The electrons in the first metal requires less energy for ejection. So now let's take VIBGR. We are writing VIBGYOR. This is 400 nanometers to this is 750 nanometers. So this side is more energy. This is less energy. So the question assertion, when either blue or violet light is strikes the metal surface, however only violet light causes the ejection of second metal. So second metal is more energy, requires more energy when compared to the first metal, right? So electrons in the first metal requires less energy only. Second metal requires more energy because second metal only violet means it is more energy. So first metal is less energy because violet as well as blue, na? The number of photoelectrons emitted depends on intensity of incident light, just now we said. The kinetic energy of ejected electrons in the photoelectric effect is directly proportional to the frequency. Just now we said frequency increases, then the kinetic energy increases. The kinetic energy of electron is increased 4 times. Kinetic energy is increased 4 times, this one. Then the wavelength. So lambda is inversely proportional to under root kinetic energy. So lambda 1 by lambda 2 is equal to under root kinetic energy 2 by kinetic energy 1. So if you do, then you will get, so it is 4 times means kinetic energy 1 is electrons increased 4 times. 4 times means, so you are going to get, it is half time. Because root is there here. So if you find lambda 2, then you will get 1 by 2 of lambda 1. The de Broglie wavelength of neutron when its kinetic energy is k. De Broglie wavelength of neutron, kinetic energy is k, is lambda. Okay, what will be the wavelength when the kinetic energy is 4k? Again, kinetic energy and wavelength only. So kinetic energy and wavelength only, direct formula you can use, this relationship you can use. So if you use, you will get the answer. Next one. Okay. So next one we'll see Heisenberg uncertainty principle and Schrodinger's wave equation like last quantum numbers. So it will take 15 to 20 minutes more. We'll finish that one. See Heisenberg. This is a very interesting story here till now. Till now whatever we discussed, the Bohr concept, the electron is revolving in a particular orbit, right? And that energy is constant in that orbit. And we can find the energy of electron, we can find the position, the radius you are finding means position also you can find. So till now whatever we learned, suddenly the Heisenberg came, that is wrong completely whatever we learned till now. Means what he said, Heisenberg said, it is impossible to find the position and momentum of an electron revolving in an orbit at the same time. Simultaneously, you can't find the position and the momentum. If you try to find position, then momentum you will get the error. If you find the momentum, then you will get error in the position. You will not get both same. At a time you can't find. At a time you can't find means then the implication is presence of fixed shells is ruled out. Fixed shells ఉంటే రెండు ఫైండ్ అవుట్ చేయొచ్చు. ఫిక్స్డ్ షెల్స్ ఉంటే రెండు ఫైండ్ అవుట్ చేయొచ్చు. అదే బోర్ చెప్పింది. సో అకార్డింగ్ టు బోర్ we can find both radius and position, and you can find the energy, and you can find the velocity. If you find the velocity, you can find the momentum also. So everything we can find. అది అకార్డింగ్ టు బోర్ కాన్సెప్ట్, ఎందుకంటే ఫిక్స్డ్ షెల్స్ ఉన్నాయి కాబట్టి. కానీ హైసెన్బర్గ్ he said there are no fixed shells. Means according to his definition, his implications of that definition, whatever he explained is there are no fixed shells. ఎందుకంటే ఫిక్స్డ్ షెల్స్ ఉంటే మనం మొమెంటము రేడియస్ సైమల్టేనియస్లీ ఫైండ్ అవుట్ చేయొచ్చు. కానీ వాడు ఏం చెప్తున్నాడు, ఫైండ్ అవుట్ చేయలేమని చెప్తున్నాడు. దట్ మీన్స్ దెర్ ఆర్ నో ఫిక్స్డ్ షెల్స్, రైట్? సో టిల్ హియర్ one story, from here another story. The formula delta x, that is error in position or uncertain position and uncertain momentum, greater than or equal to h by 4 pi. Greater than or equal to h by 4 pi. Here already I said just now, this is important. This is 2008 question. Uncertainty in position and momentum both are equal. Then what will be the, what is the formula? Equal. Then uncertain velocity you have to find. So velocity you have to find. Both are equal here. You can see uncertain position and momentum both are equal here. Uncertainty in position and momentum both are equal. So if both are equal means in the both are equal means here so both are equal. So instead of momentum also you put position, then you will get the answer. So delta x we are taking and delta p we are taking and is equal to h by 4 pi. So delta x in the when both are equal means no delta x, and here also delta x only I am taking, and is equal to h by 4 pi. So delta x square you take now because both are same. So h by 4 pi. So they are asking delta x. So delta x is equal to, this is changing, okay, delta x, even delta p also you will get because delta x, now delta x is equal to that is under root h by 4 pi. Keep the 4 pi like that only. Now this is even delta p also. So m into delta v, that is equal to under root h by 4 pi. So bring this m this side. We want only velocity. So under root h 4 pi m under root. So bring that to, sorry, m will come outside only, that is 1 by m. So delta v is equal to 1 by the 2, this is root 4 will become 2 and h by, next simple question. This is also, but it's a long back, all India pre-medical test. Next, Schrodinger wave equation. So we are not going to discuss this much here. So h psi is equal to e psi, right? These things are not that much important now at this stage, right? We'll discuss here the radial nodes, See the shape of the orbitals. S orbital is spherical in shape, right? And p orbitals dumbbell in shape, and d orbitals double dumbbell in shape. And in this one, double dumbbell shape, especially these two are very important. These two are very important, and these three are one set. These two are one set. These three are the lobes, the electron densities between the axis, and those two, the lobes, are the electron densities along the axis. Next, we are having total 4 quantum numbers: principal, azimuthal, magnetic, and spin quantum number. This will explain complete about the atom, and the principal quantum number explains energy of electron. Number of subshells in a shell, that is equal to n, and number of orbitals n square, and number of maximum number of electrons that can accommodate in an orbit, that is 2n square. 2n square. Formulas if you remember, it will be very easy. And the L values for s orbital, it is 0. L value, that is azimuthal quantum number. It explains the shape of the orbit, shape of the subshell, right? It explains the shape of the subshell. And number of orbitals for a subshell is, that is 2l plus 1. Number of orbitals means, if you take s orbital, it is only 1. Spherical means spherical. P orbital, px, py, pz. So 3 you are getting in the p subshell. So 3 p orbitals, and in case of d, total 5 d orbitals, d subshell 5 d orbitals, and f subshell, and there are 7 f orbitals. So L values you have to remember. So L value, this is L value for s orbital 0, for p orbital 1, d orbital 2, and f orbital 3. And orbital angular momentum formula, under root L into L plus 1 h by 2 pi. Under root L into L plus 1 h by 2 pi. This is represented with m, and the values ranges from minus L to 0 and plus L. Minus L to plus L including 0. So for s orbital, its value is 0, only one value. And for p orbital, its value is 3, that is minus 1, 0, plus 1. And for d orbital, minus 2, minus 1, 0, plus 1, plus 2. Right? So f orbital, here total we are having the 5 values, 1, 2, 3, 5 values, 5 orbitals. 3 values, 3 orbitals. Here only one value here, that is 0 value. This is the orientations. And you can see this is the orientations, the possible orientations of the d orbitals. Next, spin quantum number. Anyway, you know this one. Clockwise spin, anti-clockwise spin, that is upward arrow, downward arrow, plus of, minus of, right? And spin magnetic moment, that is mu is equal to under root n into n plus 2 bm Bohr magneton. For the magnetic compounds, whichever is having unpaired electrons. Nodes, we are having 2 types of nodes, radial nodes and angular nodes. Radial nodes, it represents the sphere at some distance from nucleus where the probability of finding electron is 0. This nucleus, idantha find out cheyochu, malli ikkada find out cheyalemu, ee area find out cheyalemu. Now this is radial node, right? It represents now angular node. This is nodal plane. Remember, nodal plane is very easy. It represents a plane passing through the orbital where the probability of finding electron is 0. Plane. Which plane you are taking? In that plane you can't find the electron. So these are radial nodes, and these are angular nodes. Formulas you can remember. Number of radial nodes is equal to n minus L minus 1, and number of angular nodes is equal to L value. And total number of nodes together n minus 1. Radial nodes n minus L minus 1, angular nodes L, and total number of nodes is n minus 1. So energy of, this is very important, 2025 question came here. So in case of a single electron system, we will consider only one factor, that is attraction force between electron and the nucleus. So the energy order, if you take 1s, next 1s is having less energy, next after that 2s, 2s 2p, if you take 2s 2p are having same energy, it's not having different energy. So 1s 2s is equal to 2p, next 3s is equal to 3p is equal to 3d, next 4s is equal to 4p is equal to 4d is equal to 4f. This is for single electron system. Why? Because there are no electron repulsion here. In case of multi-electron system, there is a repulsion between electron and also there is an attraction between electron and nucleus. Two factors there. So by considering two factors, you have to fill the electrons. Then obviously the energy order will be here. Even in the second shell, now 2s 2p we are having. So between S and P also there is a difference in energy. If it is multi-electron system, if it is single electron system, there is no difference. That's why we are equal. So this is hydrogen and hydrogen-like species. The energy order is this one, single electron system. For multi-electron system, we will follow the Euler diagram or else above principle. That is according to n plus L value. Whichever is having lower n plus L value, that is having less energy. Whichever is having more n plus L value, that is having more energy. And whichever have both n plus L values are same for two orbitals, then whichever is having lower n value, that one we will take it as lower energy, like 4p and 3d. So 3d we will take. Pauli's principle says that no two electrons should have same set of 4 quantum numbers. అంటే ఏదైనా అట్లీస్ట్ ఒక క్వాంటమ్ నెంబర్ అయినా డిఫరెంట్ ఉండాలి. అన్ని క్వాంటమ్ నెంబర్స్ 4 క్వాంటమ్ నెంబర్స్ సేమ్ ఉండొద్దు. Right, this is examples. And Hunch rule, what Hunch rule is saying, you have to fill the electrons in a degenerate orbitals. First you have to fill electron 1 1 1. Single electron should be filled in 1 1 electron should be filled in all degenerate orbitals with the same spin. Actually the students here are having some confusion. Is this is correct according to the Hunch rule means correct only. That is also correct. There is no rule that you have to fill with only upward arrow, that means positive spin. He said that you have to fill all the degenerate orbitals with the same spin. Then you have to start pairing. You have to start pairing. Right? Hunch rule. Next one. So electronic configuration. These are the anomalous electronic configuration. We know that chromium and copper, they are having anomalous electronic configuration because half-filled and full-filled configurations will give more stability. The half-filled and full-filled configuration stability is explained based on exchange energy concept. We'll explain based on exchange energy concept. That is, the same electrons will be exchanged. Here 4 exchanges by electron 1. This 1 electron, it can exchange with this. 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 So for each exchange, it will release some amount of energy. For each exchange, it will release some amount of energy. So the system which is having less energy is more stable. That's why the full-filled and half-filled configurations are more stable. So we'll solve few questions here. Just now we said N is explaining about the shape of orbital, size of orbital. Okay. Explaining about the orientation of orbital. Okay. N, first, sorry, this one. MEL, that is orientation of orbital, and M, magnetic. MS, orientation of spin. B4. This is spin quantum, MES. S has to be given. So MS, that is orientation of spin, that is A3 and B4. And next C, that is L. L is shape of orbital. L is shape of orbital. This is size of orbital. It's not orbital, it's orbit. Size of orbit. So answer is first option. Fine, ma'am. So we'll stop here. So practice more number of questions on these topics. So we'll stop here. Continue in tomorrow's class. In tomorrow's class, we will discuss the periodic properties, periodic classification, periodic properties. It's a small topic and very easy topic. So practice more number of questions. We'll stop here. So this is 2024 question. That is simple one, right? So we'll stop here. We'll continue in the tomorrow's class. Thank you.